Astronomers in 1996 attempted to do something extraordinary. They pointed the Hubble Space Telescope into a part of the sky that seemed utterly empty, a patch devoid of any planets, stars, and galaxies. This area was close to the Big Dipper, a very familiar constellation, and the patch of sky was no bigger than a grain of sand held out at arm's length. This was a somewhat risky move by the scientists. After all, observing time on this telescope is in very high demand, and some questioned whether it would be wasted trying to look at nothing. There was a real risk that the images returned would be as black as the space at which it was being pointed. Nevertheless, they opened the telescope and slowly, over the course of 10 full days, photons that had been traveling for over 13 billion years finally ended their journey on the detector of humanity's most powerful telescope. Their feeble signals collected almost one by one. When the telescope was finally closed and the images were processed, the light from over 3,000 galaxies had covered the detector, producing one of the most profound and humbling images in all of human history. Every single spot, smear, and dot was an entire galaxy, and each one containing hundreds of billions of stars. Later, in 2004, they did it again, this time pointing the telescope towards an area near the constellation Orion. They opened the shutter for over 11 days and 400 complete orbits around the Earth. Using detectors with increased sensitivity and filters that allowed more light through than ever before, over 10,000 galaxies appeared in what became known as the Ultra Deep Field, an image that represented the farthest we've ever seen into the universe. The photons from these galaxies left when the universe was only 500 million years old, and 13 billion years later, they end their long journey as a small blip on a telescope CCD. These galaxies, while standing absolutely still, are racing away from us, in some cases, faster than the speed of light. The space-time between us and everything else grows larger by the minute, pushing the galaxies in this image to a distance of over 47 billion light years. And because of universal expansion, the farther something is away from us, the more its light is shifted toward the red and the faster it appears to be moving. Edwin Hubble himself discovered this by measuring the redshift of many galaxies, and it's a measure of not only speed, but distance as well. Recently, Hubble scientists put the icing on the cake. Using the measured redshifts of all the galaxies inside the image, they made a 3D model of the ultra-deep field. This is how it looks when we apply the distances of the galaxies in the most important image ever taken. There are over 100 billion galaxies in the universe. Simply saying that number doesn't really mean much to us because it doesn't provide any context. Our brains have no way to accurately put that in any meaningful perspective. When we look at this image, however, and think about the context of how it was made, and really understand what it means, we instantly gain the perspective and cannot help but be forever changed by it. We pointed the most powerful telescope ever built by human beings at absolutely nothing, for no other reason than because we were curious, and discovered that we occupy a very tiny place in the heavens.